In this video, we're going to be covering Newton's second law, which is known as forces, F equals ma. So if we look at a box and we push this box with a force of F, we bring the stationary box from a velocity of 0 to a velocity of, let's say, 5 meters per second. Now, because we changed the velocity of this box from a velocity of 0 to 5 meters per second, we can call that an acceleration. Now, a force you applied equals the mass of the box times the acceleration, which is Newton's second law. So this is just a brief overview of the concept of forces, and let's go ahead and look at a problem. A mass pulley system is shown below. Determine the relationship between the masses and accelerations of the system. Assume an ideal pulley, gravitational force, and frictionless table. Now, we're given M1 and M2 in this diagram, as we can see, and we have a string attached to both this box and the hanging box, and we have a frictionless pulley. An ideal pulley, which also means frictionless pulley, and also a frictionless table, and just the Earth's gravitational force. Now, if we can look at the system, we would assume that the M2 would be pulling M1, since M2 would be moving downward due to the gravity. So let's say we have an acceleration over here due to gravity. Then because both these boxes are attached by one string that's ideally connected by one pulley, both of these accelerations would be the same. So we would also have an acceleration there. And because, once again, there's an ideal pulley, the tension of this string over here would equal the tension of this string over here. Now, this is basically the overview of the diagram. This is all the useful information that we can use to solve this problem. And let's go ahead and piece this into a mathematical equation. So let's bring this out of here. And let's go ahead and look at M1. So if you remember the box at the table, there's just an M1, and it's being pulled by the string of tension T. So let's go ahead and bring that in here. And once again, we can also bring in M2. And you can notice that I drew M2 sideways. So the reason behind why I drew M2 sideways is just because that it works, because the gravitational force is pulling it downward, it works the same way as if there were some force pulling it rightward, because M1 is moving rightward because gravity is pulling it downward. So I just made it horizontal. As you can see, let's go ahead and bring in the tension. This tension would equal, as discussed earlier, and we have a gravity over here. Now, force due to gravity over here, there, of course, yeah. So you can also do this vertically. You can have M1 point directly downward, and you can have the M2 being normally vertical, but I just kept it horizontal because I do believe that unfolding it makes the diagram look easier, because you're basically simplifying the problem into one dimension that does not change the problem itself. Because gravity pulled downward, the box on the right, or the box on the top, moved rightward. So there's just one positive direction that we can consider in this problem, and let's go ahead and consider the positive direction to be rightward or downward. So the direction of force due to gravity would be the positive one. So let's go ahead and use that information and piece together our Newton's second law equations, F equals ma. So the sum of forces equals the mass of an object times the acceleration. So in this case, we have the sum of forces equals the mass of box 1 times the acceleration of box 1, which is also just acceleration because the acceleration of the system will equal. And if we go ahead and look in this picture over here, if you notice, we only have one force being applied onto this box. Well, one relevant force, that is. You do have a normal force and you do have M1G, but I did not include that in here because it will not be relevant to our problem, since they will be vertical, and the vertical motion of that will not do anything to our problem, especially because we don't have friction. But in the future video, I will include that because that might be useful if you are doing X and Y directions, which you also could with this problem, but I just chose to unfold it to just make it one-dimensional. So if we look at over here, the only force, once again, is just T. So it'd be t minus 0 equals m1a. I didn't put a minus 0 because I didn't think I needed it, and it would just be the same thing, but t equals m1a. So that would just be the equation for your m1. Now if we look at m2, we have actually multiple forces. So the sum of forces equals m2a. Please be sure to separate these. Do not do m2a plus m1a. You're jumping too many steps if you do that. It will just be m2a if we are just looking at this over here. So the sum of forces on M2 would be, once again, we consider the downward or the rightward to be positive. So it would be M2A minus T, negative tension because it's pulling the opposite direction, equals M2A. Now, we actually have all the information we need over here. All we have to do right now is just use these two, this equation and this equation, and let's go ahead and use those to solve for our acceleration. Let's take the diagram out of the way and let's go ahead and bring the relevant equations. Now if you notice, t equals m1a and m2g minus t equals m2a. We have a t over here that we want to get rid of because t is, in this case, an unknown, and we want to have as little unknowns now in one equation as possible. We already have an unknown of a and we have an unknown of t. We just want to have one since we're just solving for the one unknown, which is a. So if we can actually just go ahead and replace t with m1a because we have the answer right here, t equals m1a. So let's go ahead and do the replacement. We would get that, and from here let's just go ahead and isolate a. To isolate a, we would just add both sides by m1a, and we would end up getting this equation, m2g equals m1a plus m2a. Let's go ahead and factor the equation out, and from here we can just divide both sides by this quantity over here, this one over here, and we would just get our answer, m2g over m1 plus m2. Now this is a very simple forces diagram problem. I'll cover more complex ones in future videos, but this one is really simple. If you had friction on the table, all that would change would just be you would have T minus friction for M1, and that would be the only difference. But other than that, this should be really simple. And thanks for watching.